look at number 5 from the notes from last time because we didn't get through all of the notes, right? Let's get number 4. So if we look at number 5, we have our horizontal asymptote and our vertical asymptote. You guys can feel free to use your graphic organizer from last time, the blue sheet, right? So here, well, first of all, the horizontal asymptote is Hoy. Vertical asymptote is Bucks, right? Bucks Hoy from Algebra 1. So that tells me that my vertical asymptote is x equals. Now, how do I find the vertical asymptote? I need to go get everything from the bottom, the denominator of my fraction, and I'm going to make it equal to 0 and solve. So I have 2x minus 1 equals 0. Add the 1, and we have 2x equals 1 divided by 2. So x equals 1/2. Yes? All right, so now I'm going to look at my horizontal asymptote, and that one is Hoy. So this one is y equals, yeah? So now, remember with the horizontal asymptote, you have to look at, well, do I have an x on the top? No, no x on the top, right? It's just negative 1. So there's no x. Okay, so that's just 0 x's, right? On the bottom, I have a what x? 2x. Okay? I mean, really, since I don't have any x's on top, well, just get rid of that. What's 0 over 2? 0. Yeah. So this is that. Y equals 0. Okay? Now, let's look at the domain and the range. Domain is which values, guys? X's or Y's?
The x.
Good. X's. And the range would be the Y's, right? So, remember for the domain, we're just going to use our curly braces.
The x such that
X with the little bar. Yup. Good. Thank you.
Equal to 1/2.
X is not equal to. And then, yup, perfect. 1/2. How did you know that you needed to use the 1/2 and not the 0?
Maybe the main x.
Good, because it has an x. Good. So then let's do the same thing for the range, except this time we're not saying x, we're saying y, right?
Yeah.
All values of y, or the set of all values y, such that
And not equal to 0.
0. Good. You're basically saying it could be any number, just not your asymptote. All right, so let's go and graph our asymptotes with a dotted line. X equals 1/2, that's a Bucks. Vertical line, up and down, right? So I'm going to go to 1/2 on my X, say it's like right there. Just eyeball that one. There we go. And then y equals 0. Y, that's a Hoy, so horizontal line. It's left to right, like the horizon, right? There we go. Okay. All right, so I have my asymptotes ready to go. Now, let's talk about the zeros. How do I find my zeros or my x-intercepts? You know, when I went to go look for my vertical asymptote, I had to take everything on the bottom and set it equal to 0, right?
Yeah.
But when you go to look for your zeros, you're going to take everything on the top and make it equal to 0. But on the top, I just have -1. Is there an x there that you can solve? No. Does -1 equal 0? No. So since there's nothing for me to solve there, you know what? Then there are none. No zeros. So what about the y-intercept? You know what then? Let's put that into the calculator. Okay? You can also plug in a 0 for that x and see what you get. But let's do that. Let's plug this whole. Alright, so this. Go to y equals. Now, what's on the top?
1, -1.
-1. Since that's all by itself, I don't need to put parentheses around it. Divided by 2x minus 1. Well, that's 2 terms, so please make sure you put your parentheses, right? And then I'm going to graph this. Let's take a look and see what it looks like. Remember, it has to look like this, a hyperbola, right?
Yeah.
All right, so let me go to, oh, you know, actually, we're looking for the y-intercept. Remember, trace, 0, enter. What is it?
1.
0, 1. Yep. So there we go. 0, 1. So when I go to graph this, remember I only want the 2 points, right? One on each side of the asymptote. So if I already have 0, 1, let's see, 0, 1.
You got 1 and -1.
You got 1 and -1?
Yeah.
So then 1, -1. So 1, -1. Yeah, perfect. Good. They're on, you know, what is it? 1 on each side of the vertical asymptote, right? There's 1. There's another one. Remember, it can't cross through the asymptotes, right? You can make it go really close because that's what it's going to do. It's just not going to cross through. And then, guys, since Sabrina wasn't here for this lesson, let's show off a little bit. Tell her what we remember. What about these end behaviors? So, Sabrina, remember like before when we talked about the arms or the end behaviors of the graph, we would say it goes up to infinity or it goes down to negative infinity, right? But remember how I told you that there was always that one option later on where it just gets stuck at a number, right? That's where we are. We're getting stuck at a number. Which number? Do you remember? Anyone remember? Huh? Yeah, what number? What number goes in here? Yeah.
H.
Yeah. Horizontal asymptote. Cindy was saying 0, which is perfect. Horizontal asymptote, which is 0, is always your end behavior. Okay? Alright? Oh, I was hoping somebody would do that. Did I do the voice thing in here?
No.
No? I know, right? Alright, so today we're going to look at simplifying rational expressions, okay? So, basically, with rational functions and these rational lessons, we're going to be doing a lot of factoring, okay? Remember, a rational expression is one with variables in the denominator, okay? If you have a variable in your bottom part of your fraction, that's a rational expression. First thing we want to do is we want to factor our numerator and our denominator. And then the next thing you want to do is you want to cancel out any factors that are in the numerator and in the denominator, okay? Right underneath it, there's an asterisk, right? Because you can only factor things that are multiplying, all right? If they have a plus or a minus in between them, you can't cross them out. Plus and minus means that they're joined together. Don't just cross them out, okay? And then the last part is you want to rewrite the expression. All right, rewrite your expression, leave it in factored form. Alright, so I think you're gonna like this. Look at 1, 2, and 3. So if I look at number 1, basically what you're looking for is anything that's multiplying. See if it's the same on the top and the same on the bottom, because then that means you can cancel it, okay? So what do you see on number 1? What's the same on the top and on the bottom?
It's 2.
The 2. And you know what? I can cancel these because it's multiplying, right? So then what's left over? 3. Okay? If you looked at this and you were like, oh, I don't remember if I can cancel it or not. Well, then go back and just look at what the problem is telling you. It's telling you, what's 2 times 3?
6.
6 over 2, which is what?
3.
3. It's the same thing, okay? So how about we look at number 2? Guys, I see a 2 and I see a 2, but be careful. Can I cross these out? No. Why?
Addition.
Good, because it has that plus sign there. Good. So this is really, what's 2 plus 3? 5. So this is really just 5 over 2, 5 halves. Okay? So let's look at number 3. All right, if you see factors in parentheses, don't start breaking things up that are inside the parentheses. It has to be all or nothing, okay? So do you see anything here that's the same on the top and on the bottom? The entire parentheses. X minus 5. So then you know what? Those can cancel, okay? But it has to be all of them. So what else do you see that you could simplify? Layer, right?
Okay.
What else can I simplify here? The 2 and the 6, right?
Yeah.
What is 2 over 6?
6.
Huh? What's 2 over 6? 1/3, right? And then on the top, I still have an x minus 3. And on the bottom, I have an x plus 3 and an x plus 4. So there we go. That is my final simplified form, right? Questions? All right, so let's look at the next one. So guys, for this next one, do you see any plus or minus signs? No, right? So, and that means anything that you see that's the same on the top and on the bottom, you can cancel it out, right? With the numbers, though, you have to simplify. So why don't we just take this one step at a time? Look at your numbers. What's 5 over 15? 1 over 3, good. And then let's go and look at our x's. So on top, I have how many x's on top? 3. So this is really this, right? If you don't remember your exponent rules, why can't you think of it this way? You can, right? On the bottom, how many x's do you have? 1. Okay. So,
You cross out.
yeah, then how many where?
Top.
Top. So x squared on the top, right? So then let's look at our y's. How many y's are on top? How many y's are on the bottom?
3.
So you can cross out the 1.
Be 2 Y's on the bottom.
Thank you. So there we go. That's it. Isn't that so fun? It's so easy. Right, Abner? No issues with this one, right? Okay. So the next one. So apparently I didn't put numbers there. What number is this? 5. So for number 5, so guys, this one looks a little bit different because, you know what? I have these plus signs here. That means even though I see an x and I see an x, I can't do that. No, don't do that. Right? Because they have a plus sign. You can't just separate them. You know, the only way that you can actually separate and kind of break these things apart is to factor. Okay? It's the only way. I know. So let's just factor the top. Look at the top. 4x plus 20. What's the first step in factoring? 3 letters.
GCF.
Good. GCF. 4. Say GPS. Does it GPA? All right. So 4 and 20. What is the? Oh my God. What is the GCF? Oh, now you got me all saying GPA. GPA is important. Right? 4 and 20. 4. Right? Okay. So I'm going to take a 4 out of there, and then you need to divide the GCF out of everything. And that's x plus what? Good. So let me rewrite this guy. Okay? So that's 4 times x plus 5 on the top. You see how we rewrote it? We kind of broke it apart, right? Now let's factor the bottom. 3x plus 15. What is it? 3. Ethan, I'm sorry. I thought you said it. Thank you, Timon. Divide everything by 3, and what do you have?
X plus 5.
Good job. So 3 times x plus 5. Oh my goodness. It's like a puzzle that just works so well, right? What can you cancel out? Huh? Yup, the parentheses, the x plus 5. So what's left over? 4/3. Can you simplify this guy even more? No, so that's it. That's done. So good. Right? All right. Any questions so far? Okay. Let's try number 6. I know it says 12 here. 6. Okay, so, all right, this one, can you go and, I have an x squared and an x squared. Can I break it apart? No.
You can do AM.
Yes, good. You cannot just go breaking that apart. Down here, you can do AM factoring, but up here, 3x squared plus 9x, what do you see?
You can combine them? Well, no, you can't.
Well, you can GCF it, right? So let me write that over here separately. 3x squared plus 9x. Guys, if I look at this, 3 and 9, what is their GCF?
3.
3. And what do they both have?
X.
An x. So 3x can come out. That means you need to divide both of these by 3x. And you get?
X.
Good. X plus 3. So I'm going to 3x, x plus 3. There we go. That's the top. That's the numerator. How about on the bottom? My AM. You guys are actually really good at AM. So x squared minus 2x minus 15. I'm looking for 2 numbers that multiply to give me negative 15 and add to give me negative 2. What are they? Good. Negative 5 and 3. Great job. So this is just a plain old x squared, right? So that means I can go straight into my double parentheses, and then I just have x and x. What kind of 5? Good. Then what kind of 3? Good. Perfect. So then I'm going to write that up here on the bottom. X minus 5, x plus 3. Oh my goodness. What do you see? What can I do?
X cross X plus 3.
Thank you. So good. And then the last step, we're just going to rewrite it. So 3x on the top and x minus 5 on the bottom. Please make sure that you keep, you know, if it was originally on the top, leave it on the top, right? If it's still left over. You just have to make sure you don't accidentally move things. You know what I mean? It'll change the whole problem. Give me some water. Alright, so number 7 is this guy. X squared minus 2x minus 8. Okay. Which factoring method for the numerator? Is there GCF? No. But you have 3 terms, so what is this? AM. Alright, let's do that AM first. X squared minus 2x minus 8. Two numbers that multiply to give me negative 8 and adds to give me negative 2. What are they? Good. Negative 4 and 2. And since this is just a plain old x squared, I could go straight into my double parentheses. Right? Sorry, my line got a little bit messy there. What happened? There we go. But how about the denominator, guys? How do I factor this? There's no GCF.
There, 1.
I only have 2 terms. Yeah, the GCF would be 1, right? I only have 2 terms. Good. It's an x squared, and there's a minus, and they both look like perfect squares. That's a dose method. Good. So we have x squared minus 4. What's the square root of x squared? X. What's the square root of 4?
2.
And with the dose method, what are the signs that go in there? One is, and the other one is good. So what can you tell me? What should I do?
Cross out plus 2.
Yeah. Cross out the x plus 2's. And then what we have left over is x minus 4 over x minus 2.
Yep.
How do you guys like this so far? Is it okay?
Yeah.
Good. All right. So, you know, if you're still having trouble factoring, let me know and we'll work on it because you absolutely need to know how to do this, the factoring in order to do this, okay? All right, so the next one. All right, first off, numerator. How do you factor this x squared minus 36? Up on top, how do you factor this guy? No, the GCF is 1, so now GCF. Good, this is dose, again. I love it, let's dose it. If you dose this, what do you get? Do we agree? Did Kevin do that right? X plus 6 and x minus 6? Cindy? Did he do it right? Yeah? Timlin?
Yeah.
Abner? All right, perfect. Thank you, Kevin. And then down here, oh, doesn't this look weird? Yeah, right?
Yeah.
Do you know why it looks weird to you? Yeah, because it's not in standard form, right? Usually the plain old number goes at the end, right?
Yeah.
We always start with the biggest exponent, we work our way down, and then our constant, plain old number always goes at the end, right? So let's rewrite this. So now I want to put the x in front, but look in front of the x. What is the sign on it?
Did you flip it the sign to add?
No, the sign in front goes with it. So negative x, right? And then look at your number. What's the sign in front of this number?
Positive.
Positive, so plus 6, okay? So if I look at this, all right, so then x minus 6 is really negative x plus 6, right? And guys, the SOLs, they love to do stuff like this. And even the E-card, they love this stuff, okay? Don't let it fool you, because what do you do if you have a negative in the front?
Divide it.
Yeah, you've got to GCF it out. So let's GCF this out. You divide everyone by -1, then you just get x minus 6, right? So I'm going to go put that there. I'm going to put a -1 and then x minus 6. And even if it is a -1, you just put negative. That's fine. Same thing.
You just cross out x minus 6.
Yeah. You cross out the x minus 6's, and then what do you have left?
-1.
On the bottom?
Okay.
You have a -1 on the bottom. How about on the top? Yeah. So you could leave it like this. It's not wrong, right? But this is really negative x plus 6. All right? And the reason for that is because, guys, if I told you 5, you would just write it 5, right? Am I wrong if I say 5/1? Not wrong. But do we really write every single number as a fraction and put it over 1? No, right? So then what if I said 5 over -1? What would you call that? This is really just -5, right? That's why, do you see how this relates to that? Yeah? You could leave it as a over -1, but it's really negative x plus 1. Okay? Good job. All right, so let's look at this one. Okay, so the top, and factoring, but this one also has a GCF because you got to divide out the what? The negative, right? So let's do that. Let's divide that negative out. Negative x squared minus 2x plus 8. Remember, we don't like when it starts with a negative. You got to take that out. And you guys have been doing such a great job with the AM factoring. I'm just going to quickly here. Two numbers that multiply to -8 and adds to a +2. What are they? 4 and -2. I can go straight into my double parentheses, x plus 4, x minus 2, bring down my -1. Yeah? Okay? Now, in my denominator, I have 3x cubed plus 9x squared minus 30x. I see a GCF. Somebody give me the number GCF, please. 3. And what else do they all have?
X.
An x. Good. So let's take that x out. So we're going to divide everybody by 3x. Then we have x squared plus 3x minus 10. And then you can just do your plain old AM, just like we were doing before, right? Two numbers that multiply to -10 and adds to give me a +3. What are they? Five and -2. Well, thank you for giving everyone a chance to try, you know? And that's the thing, you know, if you just keep doing a lot of factoring, the number combinations start, you know, just kind of, you're like, oh yeah, it's this one, you know?
Yeah.
But don't feel like you have to rush. All right, so don't forget to bring down your 3x, and then you have x plus 5, x minus 2, yeah?
Yeah.
Am I going too fast?
Yeah.
All right. Now, what can I cross out?
X minus 2.
X minus 2's. So let's rewrite this guy. So my final simplified expression is there. Yes?
Yep.
Okay. Questions? Comments? All right. Oh no. Okay, here we go. Let's look at our last one. And after this, I have a practice sheet for you, and we'll just do one more, okay? So this one, all right, so the top. Guys, it looks like an AM, but before you do the AM, what do they all have? X. So take that X out. So let's do that. We take the X out, like Sabrina just said. Here we go. And then AM. So let's see, two numbers that multiply to give me 4 and adds to give me 2. Is this possible? You know sometimes you can't like AM, right? Sometimes you just have to leave it as a trinomial. You know, this one, let's think about it. What are two numbers that multiply to give you 4? 2 and 2, yeah?
I know that doesn't.
You're saying it doesn't work? Yeah? I mean, it doesn't. 4 and 1. Maybe you have the -2 and -2, or -4 and -1. That's it. Those are all the numbers that multiply to give you a positive 4, right? None of them are going to add to give you 2. Is that 5? -4, -5. No, absolutely not. So you know what? This stops right here. The only thing you could actually do here was a GCF. Tricky. Right? So now how about my denominator? I have x to the 4th minus 8x. What do they both have? X. All right, let's do it. Let's take that x out of both of them. X cubed minus 8. How do I factor this? This is not dose.
It's a soap.
It's the soap way. Good. So remember, soap has a special 2 and a 3 thing, right? 1, 2, 1, 2, 3. Bring down your x because that GCF isn't going to hurt it. We can bring that down, right? What's the cube root of x cubed? X. What's the cube root of 8? So what goes in this first one? X squared. Good. What goes in the second one? 2x. What goes in the last one? Oh, this one. This one times that one.
4. Wait, 2 times 2?
What's 2 times 2?
4.
4. Okay? You literally get all of your trinomial terms from these guys right here, this x and the 2. Now the signs. same,
Opposite.
opposite,
Always plus.
always plus. So let's put that up there. With the GCF, don't forget the GCF. How fun. What crosses out here? Yeah, the trinomials cancel out. What else? Anything else? Nothing? Yeah, the X is on the outside. Oh yeah, they cross out.
It'd be x minus 2.
Yeah, but X minus 2 where? Where does the X minus 2 go?
The top.
Is it on the top?
Bottom.
On the bottom. You see, it's on the bottom, right? So if we only have X minus 2 left on the bottom, then what's on top?
1.
1. Good. 1 over X minus 2. Alright? So that's the last one on your notes, right? Okay, so I'm going to give you a little half sheet, practice sheet, and I want to try the first one with you, and I would like you to do the second one. And if you get it done, you can give it to me, and I'll give you extra credit. So the first one on your practice says 2x squared plus 5x minus 3 all over 2x squared plus 10x plus 12. So guys, we need to factor everything. You know, I just want to make sure that we kind of refresh our memory here. 2x squared plus 5x minus 3. Is there a GCF? Because I have a 2 in the front, and I don't like that. But 2, 5, and 3, do they have a GCF? No. So, I don't like it. So I need to multiply it over, and that gives me my new m. What's 2 times negative 3? Negative 6. My a number still stays the same. That's 5. So what 2 numbers multiply to give me negative 6, but adds to give me a positive 5? Good. 6 and negative 1. All right. So guys, remember, whenever you do the swing way,
Yeah, 6 and negative 1 replaces
the 5x, you have to bring down the first, so it's 2x squared. Bring down the last, so it's minus 3. And the one in the middle here, this guy, plus 5x, you rewrite it using the 2 numbers that you found. So you could say plus 6x minus 1x. Or you could flip it, and you could say minus 1x plus 6x. Doesn't matter, the order. But now when you have 4 terms, how do you factor this?
you split it.
Yeah, you split it in half. And then you need to find the GCF of the left-hand side, find the GCF of the right-hand side, and we have to make sure that our parentheses match. So on the left-hand side, we have 2x. Welcome back. X plus 3. And on the right-hand side, what's my GCF?
It'd be 1.
Just 1? Negative 1. Remember, starting with a negative, please bring out that negative, okay? Do my parentheses match?
Yep.
Yes. So, x plus 3 goes in 1. What goes in the other one?
X.
2x. Thank you. 2x minus 1. want you guys to do that bottom one, please. Try it out. The 2x squared plus 10x plus 12. You know, I know that there's a 2 in front, but see if that's a GCF, okay? It's not always going to be a swing. It might be a GCF sometimes. So you should have GCF'd out the 2, and then you get an AM here. And then your two numbers, let's see, two numbers that multiply to give me 6, adds to give me 5, 3 and 2. Don't forget your GCF. Yeah? So what crosses out? X plus 3's. And then you have 2x minus 1 over 2 times x plus 2. Yeah? Okay, so you guys try number 2, and then we'll put the answer up. Alright, so for the second one, guys, GCF for both of them? So this one, up on top, your GCF should have been 25, 2x minus 1. On the bottom, your GCF should have been 60. So again, 2x minus 1. What crosses out? 2x minus 1. And then you have 25 over 60. Wait a minute. Can't that be simplified? Yeah, to what? Good, 5/12, and that is your answer. You have a homework assignment. Do you have a mini quiz next class? Check your purple